Alright, this is the 4.5a homework. Number one, they want you to solve the equation by factoring. This problem is different than the last section because this actually has an equal sign. It's an equation. So we're going to be looking for the solutions to it as opposed to just factoring it. Factoring will be a step though. It's going to be the step before we actually get our solutions. The first thing you want to do is you want to get all of the terms to one side. So I'm going to move the 4 to the left hand side by adding 4 to both sides. So we're going to have 2x squared plus 6x plus 4 equals 0. This is the way that you're going to want to have it. You're going to want to set it equal to 0, and you're going to want to put it in order, and you want the first term to be a positive coefficient. Once you're at this stage, you need to check to see if there's a common factor. So factor out the GCF, which is going to be 2. So you factor that out. Now we continue factoring. This is an easy trinomial. So to get x squared, we need x and x. Factors of 2 that add up to 3, 1 and 2. So your solution, or solutions, will be what makes this equal to 0. You can say x plus 1 equals 0. Subtract 1. X equals negative 1. That's one possibility. And what makes that 0? X plus 2 equals 0. Subtract 2. X equals negative 2. So your solutions from least to greatest are negative 2 and negative 1. You might ask, what about this over here? Well, if I set that equal to 0, I don't get a solution for that. So you sort of leave that alone. So your answers are negative 2 and negative 1. And what this means is, if you were to graph this equation right here, this parabola, these are the roots, they're the x-intercepts. They're also called the solutions. But this really is where you have a good idea of what you're doing in this problem. You're finding the x-intercepts. And in general, you set y equal to 0 and solve for x. If this was a typical quadratic in standard form, you would have y equals all of this stuff. So when y equals 0, you're solving for x. You're finding the x-intercepts by doing that. All right, number 2. Again, we're going to want to move everything to one side. So I'm going to subtract 8x from both sides. So we have it equal to 0. It's in order. Is there a greatest common factor? Yes. 2 is in common and x is in common. So I'm going to factor that out. So I'm going to be left with x minus 4 inside the parentheses. Now that it's completely factored on one side, you set each of these equal to 0 and solve. So I'm going to have 2x equals 0, and I'm also going to have x minus 4 equals 0. We're trying to find out what makes each of these factors equal to 0, because when you take one thing and multiply it by 0, you'll always get 0. That's the zero product property. If a is 0, this is true. Or if b is 0, this is true. So we're finding out what would make each of these things equal to 0. So if I divide both sides by 2 here, x is equal to 0. That's one solution. And if I add 4 over here, I have x equals 4. So my answers are 0 and 4. And you want to write this out in set notation. You don't want to put it in parentheses because parentheses would imply maybe a coordinate or something. But these are actually letting you know that these are the solutions. Number 3, they want you to solve by graphing. So we're going to get our calculator out. Let me just move this over. Okay, so we turn it on. We want to make sure our window is all set. So we want to go from min to max, -10 to 10, scale of 1, -10 to 10, scale of 1. So that's all set. So we want to hit y equals. First thing you want to make sure is none of these plots are highlighted. For example, if you have something that looks like this. If it looks like this, you have to go back up here. So go up and scroll to where it's highlighted so that the cursor is blinking over it, and hit enter, and then go back down so that none of these are highlighted. It's because you might get an error if it's done like that. So let's enter this equation in. 2x squared minus 2x minus 5. Then hit graph. You should see a nice clear graph of it here. Now we want to solve this equation here. So the solutions to this are going to be the x-intercepts. So I want to find out exactly where that is and where that is. So to do that, I hit second trace, which is the calc function. You want to calculate the zeros of the function. So you hit 2. It's going to ask 3 questions. The first is left bound. The left bound going from left to right is going to be any space just before you hit the 0. So anywhere above this. So I'm going to scroll left to a space just above it. Hit enter. Second question is right bound. The right bound is going to be any space just after the x-intercept. So scroll till you go beyond that x-intercept. So you hit enter. And then you want it to guess, so you hit enter again. So your first answer is going to be -1.16, because they want the decimal to be 2 places. So round it up. So -1.16. Let's write that down. -1.16 is your first one. Let's get the calculator back. You want to find this 0 here, so let's hit second trace again. 2. So for this one, your left bound is going to be just before you hit that 0. So keep going. That's right before it, so that's good. So hit enter. The right bound is going to be right after it. So keep going till you hit after it. Hit enter and then guess, enter again. Your 0 is going to be 2.16, and you see that right here. So let's write that down. 2.16. And that's it. Number 4. Suppose a frog jump is modeled by this equation. Let's move this over here so we can graph it. How far did the frog jump? So let's get our calculator out. Let's clear out this equation. Let's enter this one into here. So -0.029x squared plus 0.59x. Hit graph. Alright, so you see it go all the way up here. We don't see where it's going to end up. So what we're going to have to do is we're going to fix our window. Right now the x-axis only extends out to 10 spaces. So it looks like it might hit probably double that. So let's make our maximum domain be, I don't know, let's make it 30. And hit graph. So you see right over here, that's where, well, this is where the frog starts his jump, and this is where he ends his jump. This is negligible here, because it won't make any difference. I mean, this if the y-axis is the height, and the x, let's say, would be the distance, the vertical distance. Sorry, it's not the vertical distance. It would be the horizontal distance. We need to find out this point here. So let's do second trace 0. Left bound is going to be any point before you hit that. So let's do there. Right bound will be right after you hit it. And then hit guess. So it looks like it's going to be 20.34. So let's write that down, 20.34. Now it could be inches, it could be feet, who knows. I would highly doubt that he could jump 20 feet. So let's just say inches. That's it. The next one is still based upon that exact equation. They want to know how high he jumped. So let's find the max here. So what we're going to do is, basically we want to find the vertex of this. So we can hit second trace. Instead of 0, we want to hit the maximum point, so hit 4. The left bound is going to be right before, going from left to right, right before you hit that middle. So let's scroll back. So it looks like it would be right around here, so any place to the left of that. The right bound would be any place to the right of that. Then hit enter again to guess. So the height is going to be 3. Because we want to find out the output, because the output is going to be how high it is. So it's going to be 3. Alright, number 6. Write a quadratic with the following pair of values as roots. Okay, so if these are the roots, they came from a situation where it potentially was factored, and these were set up equal to 0, and then these were the answer. So an easy one would be -2, because that must have come from x plus 2. Because if you set x plus 2 equal to 0 and you solve, you get the solution. For 3/2, what you want to do is use the idea or the rule that the denominator is the coefficient of x. So for this one, it's going to be 2x. This root is positive, so we're going to do the opposite sign. And then the numerator is going to be this number here. And the reason why is because if we were to set 2x minus 3 equal to 0, we add the 3, and then we divide by 2. So x is 3/2. You notice that the denominator here is, let me just do this in a different, the denominator is the lead coefficient of x in here. The numerator ends up being the thing right after the x, the term right after the x. And this was positive here, but it came from the fact that it was negative, because when you add the 3, it becomes positive. So if you ever have a root, let's say if the root is something that looks like a over b, then it comes from something that looks like bx plus, minus. bx minus a. And if the root is negative a over b, then it's bx plus a. And you can set this equal to 0, subtract a, divide by b, you get negative a over b. If you set this equal to 0, you add a, divide by b to solve for x, and you get a over b. So this is your answer right here. Well, actually, no, wait a minute. We're not done yet. They want the quadratic equation, not the factored form. So we have to FOIL this out. So 2x times x is 2x squared. 2x times 2 is 4x. Let me just write that up here. Negative 3 times x is negative 3x. Add those together, you just get positive 1x. And negative 3 times 2 is negative 6. This is your answer right here. So once you get it back at the factored form, you FOIL it out, and you get your quadratic. Alright, number 7, factor the expression. First thing you check is order. We're good. Next thing you check, is there a greatest common factor, or is the lead coefficient negative? No greatest common factor, and it's positive, so we're good there. And then the next thing we want to check, is it special? The answer is no. The ends are not square roots. So we're going to have to use the box method on this one. So let's do this. So we're going to have the 2x squared here, the minus here, minus 7. The AC is 2 times 7, or 14. Let's write the combinations here. The negative says they're different signs. The larger number is going to be positive. Which one adds to a positive 13x? It's going to be the top one. So let's drop those in. Negative 1x and 14x. This is positive, 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 negative. Let's factor out. We have a 7 here. Factor only an x. Factor 2x. Factor the GCF. We have a 1. So the answer is going to be 2x minus 1 times x plus 7. Now they don't want you to solve because, well, there's no equal sign here, so it wouldn't make any sense for them to say solve. They just want you to factor it. It's a review problem. Alright, number 8. I want you to graph the parabola. So we're going to want to try to find the vertex. So the opposite of b divided by 2a, that's going to be 3 divided by negative 2/3. So 3 over 1 times the reciprocal, negative 3 over 2. It's going to be negative 9/2. So that's the h. So negative 4.5. Let's find the k now. So negative 1/3 times negative 9/2 squared minus 3 times negative 9/2 plus 4. Now don't freak out when you see something like this. You just got to work with it. Negative 1/3. The negative squared is positive. 9/2 squared is 81/4. A negative 3 times a negative 9/2 is a positive 27/2 plus 4. Alright, so we have negative 1/3 times 81/4. So 3 goes into 81 27 times. So that's negative 27/4 plus. You want to write this in terms of fourths. So we're going to double this. So that'd be 54/4. Let's make 4 in terms of fourths. That's 16/4. Alright, so let's see here. We've got 54 and 16 together is 70. Minus 27. You get 43/4. which is 10 3/4. So 10.75. So negative 4.5 comma 10.75. So we're way up here. That's your vertex. The y-intercept is 4. So let's hit right there. And it's negative 4.5. So it's going to be negative 4.5 to the right. So negative 4.5 to the left. So it'll be 1, 2, 3, 4.5. So it should be 9. Negative 9. So we have the symmetry here, and then it should be relatively good enough to draw a parabola. That's what it should look like, roughly. Number 9, graph the absolute value equation. So what we can do is we can do an XY table. It's awfully ugly, but what are we going to do? So negative 3, let's not write in height in that color. Let's do negative 3, negative 2, negative 1, 0, 1, 2, 3. So negative 3 times 3 is negative 9. Negative 9 minus 6 is negative 15. The absolute value of which is 15. 15 plus 1 is 16. Negative 2 times 3 is negative 6. Negative 6 minus 6 is negative 12. Absolute value is positive 12 plus 1. 13. So if I were to plot that, it would be like right around here. Negative 1 times 3 is negative 3 minus 6 is negative 9. Absolute value is 9. 9 plus 1 is 10. So we see that we're going down by 3. So 0 times 3 is 0. 0 minus 6 is negative 6. Absolute value is 6. 6 plus 1 is 7. You can do all of these out. So 1, so that would be 4. 2 would be 1. And 3 would be back up to 4. Then, I mean, you could keep it symmetric on both sides because it's a V. So let's draw these lines in here. Let's straighten this one out a little bit. And let's throw on a couple of these arrows. So that's what your graph is going to look like. Absolute values look like V's. Remember, parabolas are smoothed. This is not a parabola. A parabola would be nice and smooth and would look more U-ish, if that is a word. 10. Explain in words. Whoopsie daisy. 10. Explain in words how knowing the location of the vertex and the orientation of a parabola can help you determine how many zeros it will have. Okay, so the location of the vertex and the orientation. Well, if you consider if a parabola has a vertex, let's say above the x-axis, and it opens up, it's going to have no x-intercepts, no zeros. And the only other possibility is if the vertex is under the x-axis and opens down. That also has no zeros. Now, when is it that it has 1, 0? Well, the only time that happens is if the vertex is located on the x-axis. It has 1, 0. And what about the times when it has 2? Well, if it's above the x-axis and it opens down, it has 2 zeros. If the vertex is below the x-axis and it opens up, you're going to have 2 zeros. So what you would explain is if the vertex is located above the x-axis and it opens up, right here, or if the vertex is below the x-axis and it opens down, then you will have no zeros. If the vertex is located on the x-axis, regardless if it opens up or down, it will only have 1, 0. Finally, if the vertex is located above the x-axis and it opens down, or if it's below the x-axis and it opens up, then you will have 2 zeros. That's basically what you would need to say.